All right, welcome back, math fans. We're gonna look at another parabola here, and this time we're gonna look at parabolas, and we're gonna start with this form of y equals ax minus h squared, and we'll start there, but we'll build to this ax minus h squared plus k. But for now, we're gonna keep our first problem nice and simple because we've moved parabolas. What we've done so far is we moved parabolas up and down, right? Up and down, or we made them wider, or we made them narrower, right? But we haven't moved them side to side yet. So, spoiler alert, this is going to move it side to side. And so, the very first thing that we're going to take a look at, we're going to take a look at this function. This will be our example one. We're going to look at y equals f of x equals, let's call this x minus 2 squared. And what we're going to consider here is, let's make our table of values, and then I'll give you a consideration on how it moves horizontally, that left, right. And it's not as intuitive as you think. The very first thing I'm going to do, though, is instead of going -3, -2, -1, 0, I'm going to start at the place where it makes this center 0, where it makes this square 0, because that's going to be where my vertex happens. So what makes x minus 2 equal 0? Well, x minus 2 equals 0 only when 2 is 0. So I'm going to start at 2. And then I'll have 3 up and 3 down. So I'm going to start at 2, 1, 0, -1. And I'll do 3, 4, 5. So I'm going to start where this makes x minus 2 equal to 0, right? And that's happening there. Okay, as we do this, I know immediately that my value here is 0. That's good. 1 minus 2 is -1 squared, and -1 squared is 1. Okay. 0 minus 2 is -2. -2 squared is 4. And -1 minus 2 is -3. -3 squared is 9. And symmetry, we have the rest of the points. Hey, this looks very familiar. The numbers on the left have changed, right? These numbers on the left have changed, but the numbers on the right haven't changed from my original, right? So that's the idea. This is going to be y equals f of x. You could also, if you want to do a second transformation table, you could do like one thing that I could show you here is you could be also doing x minus 2 like that. And so I know that a second transformation table has helped people that you're doing things in order of the transformations. And so this would have just been -3, -2, -1, 0, 1, 2, 3, right? And now we have our original column of x's back, and we get our classic regular parabola values, our regular y values here, right? So we're seeing, oh, okay, we're just moving this left and right now. So what's going to happen is that this parabola, even though it looks negative, has moved it right. And it's basically what how we decide how it's moved left or right, and like where it's going to be centered on, is we're thinking about what it takes to get back to 0, right? What it takes for x to get back to 0. So if it takes +2 for x to get back to 0, then it means it's moved to the right, not moved to the left, right? It's about getting back to 0. So our first point is going to be 2, 0 right here, right? Our next point will be 3, 1 right there. Negative, +1 and 1, 0 and 4. And then it would be 5 and -1 and 9. So 5, 6, 7, 8, 9 right there. Then by symmetry, we got the rest over here. And it has the same shape as our regular parabola, except now that it's moved over 2 units to the right. 2 units to the right, it's moved over. So it has the same shape, except now it's moved over. So we're going to see that h value, right, in general, we can make this conclusion that h moves left, right. And what we're going to get is that since we have x minus h squared, here we had x minus 2. And if we had x plus 2, it would move the other way. So this would be moving right, moves the function right, and this moves it left. So what that would mean is that we would definitely have to choose some values of x. This is technically actually, if I had a positive there, it'd be negative negative 2. Right? So it's always negative if I had a right, because the equation that we use to state our parabola form is x minus h. Good. Let's take a look at one and just apply some transformations to it and see what we can do, right? So we're just going to add some more fancy features to it and make this work out for us. Let's apply some features. So example 2, example dose. Let's take a new function. We're going to call it y equals, let's say, negative 1/2 x plus 1 squared. And we'll leave it, we won't apply any fancy k to it just yet. And what we'll do now is do our x values and then y equals f of x as our other column. And let's just start it there. What I'm going to see here is my middle value to get this x minus 1, or sorry, this x plus 1 back to 0, x needs to be negative 1. So that's going to be the middle value that I choose here. So 1, 2, 3. This is going to be negative 1. That means above will be 0, 1, 2, and below will be negative 2, negative 3, negative 4. All right, let's just fill everything in. I know that's going to be negative 1 plus 1, that's 0. 0 squared is 0. That's just going to be 0 here. I know 0 plus 1 squared is 1. 1 times negative 1/2 is negative 1/2. 1 plus 1 is 2. 2 squared is 4. 4 divided by negative 2 is negative 2. And then here, I could actually say we could put negative 5 and 3 here just so that we get some nice even numbers to work with. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times negative 1/2 is negative 1/2. This is going to be negative 2 by symmetry. Let's look what negative 5 is. Negative 5 plus 1 is negative 4. And negative 4 squared is 16. 16 divided by negative 2 is negative 8. All right. And 3 will also be negative 8. 3 will be 4 squared. Let's just try 2 and get negative 4 by symmetry. 2 plus 1 is 3. 3 squared is 9. This will be negative 9/2 or negative 4.5. Right, so negative 9/2. So this is for sure opening down. It has its vertex on, so this one, the vertex was at 2, 0. Right, the vertex for this one, right away we know that this is at negative 1 and 0. So axis of symmetry, we know right away is at x equals negative 1. We don't have a y-intercept right away. It looks like the y-intercept, we'll find out what that's going to be. But we don't, actually, we know the y-intercept. We know it's this value right here. It's 0 and negative 1. We have one x-intercept, that's negative 1 and 0. Let's fill this in. Our range, our maximum value is 0. Everything else is negative. So that helps us out, that we know that we can keep everything kind of below the x-axis, so we can, focus on the negative quadrants that we want to key in on here. So this is x, that's y. And then I know my first point is going to be negative 1 and 0, right? That's the vertex point. And this is going to be 0, negative 1/2. This will be negative 2, negative 1/2. 1 and negative 2 is over here. Negative 3 and negative 2 is over here. Negative 5 and negative 8 is 4, 6, 8 down here. And then by symmetry, 2 over from this one, right there. And let's get that 4.5 in just for completeness. So that would be right there and right there, right? It follows a very predictable pattern, even with A values, right? That we can kind of do this enough times and you can start filling it in very easily based on the patterns that you establish. Good. And it just goes down, and we can see that the vertex is at -1 and 0. So this is just moving things back and forth, keeping things nice and simple for us. All right, let's do one more graph, and then we'll try some other examples here of us going into some solving and finding equations of a given function. So this one will be example 3. Actually, let's see where we're at time-wise. Time-wise, do we want to keep going? Let's stop it here. We'll start example 3 and do some algebraic solving in the next one.